My name is River. I work at PlayStation, and today I'm going to be briefly talking to you about interprocedural IR outlining in the context of code size optimization, what it is, what it can do, and where we might be able to go with it. Is that it? There we go. So why am I talking about this? Well, first of all, code size is still extremely important. Hello, embedded systems. But also, outlining is kind of low-hanging fruit in LLVM. There's some support for it, but there are a lot of opportunities for what we might be able to accomplish. When I'm talking about outlining for code size, what I'm really talking about is finding equivalent sequences of code and abstracting that to a function call with a shared implementation. So things like the easy examples of this are functions with constant parameters, macros, templates, inline functions, your common cases of code duplication. A quick algorithmic overview of what we're trying to accomplish right now at the IR level is performing a common substring query based upon a value numbering of instruction chains. So this value numbering, unlike traditional value numbering, we don't actually care about the value used in the computation. We just care about the operation itself. So after we've identified some candidates, we select inputs and outputs from the sequence, do some cost modeling and basic analysis, and then outline any profitable candidates that we found. Inside of this process, we perform a bunch of different optimizations and analysis that reduce the cost overhead of the new function calls, but details for that will be available online. So below you can see a pretty short example of what we're trying to accomplish with this. You have a stir compare followed by a result check. This is small, but it's a common pattern that you'll see across code bases. This is a small example, actually. I've seen it reach tens, hundreds of instructions inside of the outline chain. So this is an optimization that's generally performed at the machine level. So why am I pitching at the IR? At the IR, we suffer the crux of every other IR optimization. We have an inaccurate cost model for the target. We never can be really sure about whether an instruction will be lowered or not, given that instruction selection patterns, matching, things like that will happen. And we're also kind of limited by the abstraction level itself. We can't exactly abstract or separate the costs for things like global addressing, parameter passing, or those are constant costs. Although we have this inaccurate cost model, we do get a lot of benefits from placing it at the IR. For example, there's a lot more opportunity. During CodeGen, things like instruction selection, instruction scheduling, register allocation tend to create a lot of slight variations between the code that, because we're trying to match, create problems. We also have a lot of flexibility in the pipeline. I mean, we have the full view of the scalar optimization pipeline as well as inlining, so we can choose where we place it in the pipeline, run it multiple times, that kind of thing. And we're target independent out of the box. That means that we don't have to have any kind of special case logic for function construction, parameter passing, or volatile ABI characteristics. So a condensed performance overview of what the current outliner can perform on Spec 2006 over around 5 different target configurations. We have 2 different placements in the pipeline, early, which is pre-inlining, and late, which is pre-instruction selection. You can see that although we don't have as accurate of a cost model as we would at the machine level, we do have fairly good performance for preliminary results. And this is just condensed results, full details, as well as LLVM test suite, comparisons of the current machine outliner, how close we actually get to estimating the actual size cost of a function. All of this is available online. So outlining the future, because you gotta have at least one outline joke in this presentation. Currently existing in Tree is a machine outliner for x64 and ARC64 that can be enabled with no red zone, and also the outliner that's in progress, which I'm kind of detailing here, but there are a lot of opportunities for what we can accomplish for outlining. For example, we could adapt something like this to pre-register allocation or even have multi-basic block outlining. So all of these different outlining methods tend to share a lot of common functionality. So we've been abstracting that candidate selection, pruning, to utilities. So if someone wants to come along and implement one of these outlining methods, a lot of the groundwork is already accomplished. And even the relaxed equivalency analysis that is detailed in this presentation is already IR agnostic for the most part. So adapting something like this to pre-register allocation is just the function of replacing the target independent bits. So more info is available online, multiple RFCs, or even full performance data if you're interested. And thank you.